Stop. Okay, excellent. So we're on YouTube. I'm going to switch you to the desktop. Desktop. Share. Hide. Excellent. En so, opsomming in Afrikaans. So, as ons net 'n datatype het, 'n klas, kan ons wat is dit nou? Suffer. As ons net 'n klas het, kan ons enige van sy statiese metodes enige tyd gebruik. En ons het die hele eerste semester gedoen en dit baie nuttig en baie programme word net so geskryf. Maar in die tweede semester wil ons leer van objekte-gerelateerde programmering. En daarom skep ons nuwe instansies van objekte. So color C1 is 'n nuwe color, maar heeltemal 'n nuwe objek. Daardie objek kan data waardes bevat, stoor en ons kan hulle verander of toegang tot hulle kry of iets doen met daai objek veroorsaak om iets te doen deur instansiemetodes te roep. Soos geen wat hier is nie, maar ons sit in die klas hierdie instansie-metode geroep, C1.brighter. So dit is 'n metode wat net op C1 inwerk. En in hierdie geval verander dit in C1, maar hy skep 'n nuwe color, instansie, 'n terugstuur, wat ons dan aanstuur vir set-pen color. So net hierdie konsep van die verskil tussen statiese metodes en dataklasse en instansies van objekte met hulle instansiemetodes en hulle instansiewaardes waarvan ons klomp objekte kan hê. In hierdie geval van C1 en C2 wat met verskillende objekte is. Okay, right. I'm going to switch back to English. What did I want to tell you, show you? Tomorrow we have a TAT, and I didn't have time this morning, but on this page, you can see the TAT, so let's switch to being a student. I'm a little student. I know students don't talk like that. Hi, I'm a student. Oh, you can still see it. I never mind. But the TAT will appear in that tutorial section which you might not be able to see, and down below. And I'll also put up a list this afternoon. I have a few meetings after this, but this afternoon I'll put up a list of who goes where. That's what you want to know, isn't it? Who goes where? Who goes where? Yes?
Well, the TAT will be 1.5 hours long, so I still would be a full 3 hours.
It'll be 1 3-hour TAT where we all enjoy ourselves. And that sounds immensely long since compared to last semester. But there'll be no tests. And the idea of the TAT is not to force you to be there and to, it's really just to give you time to practice. Because, let's face it, you don't need me. You can all read the book by yourselves and then program it. Why is there a university at all? Well, the bottom line is that when we study something on our own, it's just not as disciplined. So I've never been able to learn any subject from a book. Working with other people, studying with other people, you can really sit down. Well, now it's too late. Learning with other people in a disciplined way is the best way to learn a subject. And more than that, you need that face-to-face interaction with other people, even if it's your peers. It's a good thing to discuss problems with other people, to work together on problems. And of course, the demos are there as well. So the best way of teaching is still face-to-face. After 1,000 years of 2,000 years of trying to teach people, no, more than that, 2,500 years of teaching people, we still don't know how to teach. And the only method that we really know is work is one-to-one, not one-to-one, but face-to-face. Me standing in front of you, looking at your beautiful faces, and you sitting in the TAT and looking at the Zemi's beautiful faces, and that's how we learn. So the TAT's 3 hours. You really don't want to come, you don't have to come, but if you are able to program, you can finish it easy peasy, and there'll be interesting stuff. In TAT 3, we're going to do voice recognition, stuff. I don't know, stuff. I wanted to do face recognition, but I think it's only a partial thing. Never mind that. What did I want to do next? I wanted to just test my little gimmick. Where is my little cable? I pulled it out last time, but I think I plugged it back in. But let's pull it out again. And let's put it in this computer and see what happens. So now I've actually gotten as far as installing the software. We need I feel this has not gone as well as I'd hoped. Visualizer is not connected. I know it is, I've just connected it. I'm connected, there I am. Aha. Okay, this is brilliant news because now I can draw pictures. When I studied computer science, before the invention of objects, we still had data structures, data types that we had to learn, and we drew little pictures. I'm not going to draw one now, I'm just going to do a little test picture. Okay, my hand is right side up. Visible and clear. Okay, fine. So YouTube will be able to see what I do. I mean, I could have used this before, but it wouldn't have been recorded. Okay, fine. So, what did we do last time? We just looked at this little program, it draws those Albers squares, different colors, and it's like the first step in learning to work with objects. So then we looked at luminance, and I asked someone, pencil or diesel. Pencil, okay. Okay. Painting is also the same. What is that about? Okay. Gabriel, look around. See, that's what happens. I don't understand that I put it across. This has happened so many times. Okay. But I asked him about this luminance story because we want to write a whole program to check luminance. And luminance is just the quality of a color, it's the brightness. And the idea is that if you put a bright color on another bright color, you can't see what you've written. So that, Jordan, but look at the window. It's making me think there's someone there. What if that story I'll think of it again. Something about manipulating your lecturers, making them walk side to side by looking in certain places. We'll get back to that as an experiment. Okay, so luminance, brightness. How do we calculate the brightness? It's a little formula. We can actually calculate the brightness, and I kind of bullied Gabe into giving some answers, but the bottom line is it's all on the next slide. So this slide says that luminance will be somewhere between, well, maybe it doesn't say that, but 0 and 255, the luminance value, and that if we want to see a color on another color, we should really aim for a luminance that's greater than or equal to 1 to 8. Remember we guessed about 10%, 20 yesterday? The 1 to 8 is the right value if you want to be able to see one color on another. So this little example has a luminance difference of 256. Well, I just said 255. Well, I guess it's a rounding error because it's double we're dealing with. That's 208. You can see the white on the blue, dark blue, because the luminance is, the difference in luminance is 208. Here, the luminance is only 105. You probably can't, you can barely see the black on the maroon. There is 47. There's a number there. That's 28. That's 14. So if the difference in luminance is low, you can't see the foreground and the background. You can't distinguish them. And we wrote this little formula by hand, but here they put it in a routine. A static routine called compatible that we can add to oh, didn't we write this? Did I do it in Albers? Oh, here we go. So we calculated the luminance of C1 and C2 and subtracted them to the absolute value. We said that's less than 20, these colors don't show. We now know that this is really 125. And if we add that routine on the slide to the luminance class, we can just call that routine compatible. But I'm not going to do any of that, because by now it's easy peasy stuff and we want to do something more exciting. This is not more exciting, but it's okay. Here is another routine we can add wherever we want, I guess again to luminance. That's called 2 gray. And the idea is that you give it a color, C, as a parameter, and it calculates a second color that is all gray, but it's the gray that corresponds to that color you've supplied. So you know that you can see in, let me read that. You know what grayscale is? Who knows what grayscale is? 3 people? Okay, who doesn't know? And the rest are the same of apathy. So black and white movies are not black and white. As you know. Black and white pictures are not black and white. They're not only black, only white, except for about a couple of movies. What was that movie called? The one that's all black and white. Nobody knows it? Still going like Renegade, they actually took a movie and converted it to physical black and white. And it's done very well, it's all fancy, comic style. In any case. Oh! My second screen is on my oh. Oh, there we go. There it is. Now, when you see movies, they're actually gray. They're all shades of gray, because that's how you can tell what's going on. So black and white movies are really grayscale, different shades of gray. And often we want to convert the color to grayscale. For example, if I have a document that's a picture that's in color, and I want to print it on my printer, but it may not be able to accept color images. Only wants grayscale images. Or if I just want to preview and see how will this look on the printer, I need to convert that color image to gray. So I can take a color, which once again you can't see, but that's blue, orange blue, and I can convert it to a gray color. And the way we do this is to first calculate the luminance Y. So we know that luminance, lum, C, sends back a double, because we implemented it on Monday. So I take a luminance of the color, its brightness, I round it to the closest integer, and then I cast it to an integer. And now the double is turned into an int. I store that in the variable y, and I make a new color called gray, and its R and G and B values are all y. So they're all equal, that's a gray color, and that's what I return. I return this color gray. No idea why they put black on here. I guess just to show that this color doesn't convert to black. Not all colors don't go to black and white, they go to some shade of gray. Maybe this stuff is too easy because you're really bored. So this slide should have come much earlier, but I will now use my amazing powers of drawing, artistry, if I can find my little thing to do. Because I've wanted to draw this picture for a while, and it's an important picture. Forget about the little man. Okay, fine. So let's just go through this whole story. How am I going to do this? Can I? Excellent. Okay, right. And now, just give me a second. I know what I'm doing. Let's do this. Let's take this one. Okay. So you lot. Okay. I'm going to have to turn your necks for a second. I'm going to freeze this. Technology. I love it. Okay, right. So we're going to execute this little routine, and we're going to draw what happens to all the objects. So firstly, this routine sits in a data type called luminance. Oh, cool. There we go. There's luminance. But it's not an object. It's a class. It's a data type. So just give me a second. A little brighter. Cool. Right. So luminance. Okay, I'm so sorry. Since this is the first time, it needs some adjustment. I want this to be brighter. It's dark to me. Okay, never mind. Luminance is a data type. It's not an instance of an object. Even though I could create instances of luminance, I could say, I want L to be a new luminance. Okay. When I do this, Java will create a new object, instance of luminance, but I need to tell it, I need to send parameters to its constructor. What parameters can I send to the constructor of luminance? Well, you probably don't know, and I don't know either, because it doesn't quite make sense. But let's have a look. We have luminance right here. Well, that's just a definition of luminance. But I can't see a constructor. We don't even know what a constructor would look like. So the fact is that luminance has no constructor. This class, public class luminance, has no constructor, and so therefore there's no parameters I can pass. In fact, it has a default constructor, which is just takes no parameters, it does nothing. So it does have a constructor, it's just invisible, the default one, and I can do that, and Java will comply. It'll create a new instance of luminance. And it'll create a variable L, and L will contain a reference or a pointer to this new object. This is not exactly what it will look like in the memory, but roughly this is accurate. This is stored somewhere in memory. It has some address. Let's say it's A12, and inside here will be the value A12. Okay. But there's not much I can do with L, because it has no values. This luminance class doesn't have any values, and it has no operations. It only has this one static method, lum. And I can call that using L. I can call luminance. I can say L.lum with some color. So if there's a static method, I can actually use an instance of this method class, and I can invoke that static method. But there are no other operations I can invoke. And in fact, I didn't need L to do this. Because lum is a static method, I could just have written luminance.lum with some color. I could have done this as well. I didn't need L to invoke lum. Lum is static, it belongs to the whole class. Lum sits right here. It's a method I can call. Okay, fine. So yes. I'm pretty sure. Check it out. Let's not stay in the darkness, but move towards the light. Albert. Okay, let's mess up this code a little bit. That worked, good. Let's say Albert. Okay, just a second. My Eclipse is just thinking. I'll be honest, I'm taxing this laptop because it's doing a lot of things. It's recording YouTube, it's running the Chrome browser, the Copy Connect, and text memory, and it's running Eclipse and this new. Okay, so I can say Loom. I'm just going to pause it now. It happened. Okay, so I can call LUM like this, but it's not a good thing to do. We don't almost ever do this. So I'm going to comment this code because it's not the done thing. What I really wanted to show you is what happens inside Luminance. What happens when we call LUM with some color. So back to the literal drawing board. If I have some color C1, I've got that variable, and it's an instance of a color. So C1 is just a reference to an instance of the color object. And unlike Luminance, color does actually store value. Every instance stores its own R, red, green, and blue value. And it has a lot of operations that I can execute on this instance of color. So I've got C1, it's an object, it's a reference to some instance of the color class. Now I'm going to call luminance.lum, like that, and I'm going to pass it C1. So, I thought I was going to do gray, but I'm not, clearly not. Antifreeze. Slides. These. And back to my beautiful drawing. Okay. So I'm going to call now, and I've just sent it C, the color. So inside this LUM routine, let's say this is the LUM routine, and it receives the color C. C is like a local variable, it's a parameter that I've passed to LUM, and I've actually sent it C1. So inside here, there's this variable. It's also stored somewhere. Let's say it's stored right there. I pass it C1, which is this value, this address, which is a reference to this instance of color. So C itself is also pointing to that color. C1 used to point to this instance of color, the values, operations. I'm calling luminance.lum C1, so I'm passing C1 as a parameter to this routine. And inside this routine, its parameter is C, which is just like a local variable, and it's also pointing to that instance. Okay, what's the next step? A declaration. Create an integer R and make it equal to that value. So I create a new variable called R. It's an integer, and it's equal to C dot get red. Get red is an operation in this instance. So I'm going to apply to C, and it's going to send back the red value. So let's pretend that was 10. Get red is invoked, it sends back the 10, the value of red, and that's stored in R, local variable R. So this assignment, declaration and assignment, created the local variable, it invoked an operation of an instance, C, that returns the value and we store that in R. And the same for G and B. So there's G There's B 20, 90, 90. Okay. Okay, last step. Oh damn, no, this isn't what I want. Oh, no. Let's pretend everything's fine. Last step is calculate this value using these integers. Multiply them by those real numbers and send them back. Is it sending back an object? No, it's sending back a double value. So it will send back some double value. I don't know, I'm going to guess it will be 40.7. And that is sent back by lum. So when we invoke lum, it does not create a new object. C is not a new object. It's simply a reference to the same object that C1 is a reference to. No new objects were created, except that I expected there would be, but never mind that. It just calculated some local variables, declared and created some local variables, calculated the values, and calculated a double value and it returned that. This is not at all what I want to show you, so I'm going to draw a second picture. My last piece of paper. Fine. Okay. To antifreeze. Go to gray. Come on, computer. Okay. Freeze. Let's just do that routine. Okay. So we know the story by now. It's easy peasy. Once again, we put this routine in luminance. So there's some class luminance somewhere. Luminance. It's got a lum routine. It's static, so it belongs to the whole class, the whole data type. It also has a toGray routine. I've still got my C1. It's pointed to an instance of color. So it has a red, a green, and a blue value, and it has its operations. Now I'm calling luminance dot toGray C1. And let's say I store that in a new variable color D1 equals, is this neat enough? Yeah, that's it. Okay, fine. So this is the code I'm executing, and I'm invoking that routine inside luminance. So when this routine executes, what will happen? toGray. It takes a parameter color C. Is that me? Let's hope not. All switch off my phones. Good. Right. I'm in gray. It has a parameter color C. I'm passing it C1. So C will point to the same thing that C1 is pointing to. It's a reference to this one instance. Okay, next thing. Local variable y. So luminance will create an int y, and that toGray will create an instance local variable y. Yes.
So you don't have to say C.
Sorry, just repeat that because I didn't hear. I don't have to say. Or I don't just reflect you what I heard. I don't have to say see what. But that's not what you're asking. See. I hate Spanish students. See. So I'm not sure what you asked, but I'll give you a couple of answers and you choose the one that's most appropriate. Okay. This is not called C1, this is called color C, and this static method can call its parameters what it wants. There's no need for its parameters to correspond to anything outside this method. When I invoke the method, right here, as it happens, I'm passing object that is called C1, a reference that's called C1. But it doesn't have to be called C1, it could have been called color 1, or my color, or that color, or gray, or whatever, blue. So there's no correspondence between C1, you see here, and C, you see there. C, do you see? C. Excellent. Okay, maybe that answers the question, maybe not. I tried my best. Right. Oh, okay, cool. Right. Local variable y is an integer. It's equal to this really complicated formula, which involves invoking the LUM routine, which is also in luminance, and passing it. Okay, right, now things are confusing. I'm passing it C, I'm passing it the reference that I just got. So this reference, whatever it is being passed to LUM. And it too is temporarily pointing to this instance of this color. And it's also called C, but it's not this C. These are two different variables. This is local to gray, this is local to LUM. So it will calculate the luminance, which for our purposes will be equal to 50.61. And this routine will disappear once it's finished execution, and this reference will disappear. It will no longer exist. Okay, so it's filling back 50.61, but I round that to 51. It's still a double, so it's 51.0. I cast it to an integer, so now it's just 51, and that's the value I store in y. 51. Okay, next step is to declare another local variable called gray. Gray is a color. So it's a reference to some color, instance of color. But gray is not also going to point to that color instance. Because here we say, make a new color object. Oh, Java's just be happy. A little relief from the tedium. Makes a new color. Gray is pointing to that color. And in its constructor, for its constructor, I pass y. 51, 51, 51. So Java will set up this new color object, this new instance of color, RGB, to have the values 51, 51, 51. It has its own operations. Fine. And then I send back this gray. So gray will go back. This reference will go back, and it'll be stored in D1. So D1 will also point there. Two observations. I must be confusing the hell out of you because I keep on talking about data types, classes, types, objects, instances, and the fact is that all these words, all these concepts have specific meanings, but we all conflate them from time to time. So to be absolutely clear, luminance is a class, and color, wherever it might be in the world, okay, so that is really a class, and that is really a class. That's Java terminology, and it's also what most people call it when they talk about these things. Sometimes they say these are objects, but that's a little crossing the line, because objects usually refers to these things. That's an object. And that's an object. But object is a little bit in between. So to be absolutely clear, you can say that this is an instance. An instance. This object isn't Auto-focusing? No, not really. This object is an instance of class color. And that object is an instance of class color. So instance is really the word we should be using. And we'll try to use consistently. This is an object, but as I said, sometimes people also call these things objects. Luminance, color. So what's the deal with data type? Well, forget about object orientation. In computer science, when we store data, complex data, it needs to be represented in some organized way. And we refer to that organized way of representing a color or the student record as a data type. So data type is at a higher level. Data type is here. These things are data types. Sometimes data types are not classes. Data types are not classes or objects. They're an abstract idea of storing data, some organized way with values and operations to be performed on those values. Some languages do not have objects at all. They can still store data types. They still have some way of storing the values associated with certain kind of data and the operations associated with that certain kind of data. In Java, the most convenient way is to have objects, so classes. Luminance, which doesn't have any values, it does have operations, and color, which has values and operations. And then we create instances of these classes, and we manipulate them by calling constructors or specific methods or static methods. Yes.
Since luminance it doesn't hold and
yes.
Not an object.
So, luminance, we still call that an object or a class, because in Java, that's really the only thing that exists. Everything belongs to one other class of object. Something like luminance is definitely also a class. We call it that. We explicitly wrote class luminance. Now, is it an object? Once again, people are not very strict about when they use the word object. Definitely, we can create instances of luminance, but it's a little pointless because everything we can do with an instance, we can also do with the whole class. It has only static methods. This slide has only one static method. So it would be pointless to create instances of luminance, but that doesn't necessarily mean it's not an object. You can think of it as an object that stores no values, but does have operations.
Then wouldn't it be a library? It's mostly for use in color.
Okay, I'll admit I lied to you. Whenever I used library in the past, the whole of the first semester, from end of January to start of May, whenever I said library out loud, in my head I was going, oh, I actually mean an object. You'll never know. So, Java libraries are really just objects. Library is one of those words that belong up here. It's almost an abstract idea that a library is code that's provided for you. You don't have to write libraries, although we can write our own libraries. A lot of the time we don't have to. Java has output libraries. Java has networking libraries, Java has graphics libraries, all provided for us. It's just a grouping of a lot of functionality that is isolated in some way. Of course, we can write our own libraries for functionality that we isolate somewhere else, but library is an abstract word, and different programming languages have different ways to make libraries or to create libraries. So many people would say, almost everyone, that when we're using color, like so, we're really just accessing color from the Java library. Maybe these abstract concepts are difficult to grasp fully, but really library is just an object or a collection of objects. have the same functionality. So AWT stands for something Windows something. Doesn't matter, but it collects a lot of graphics. Objects that relate to graphics, and color is one of them. Oh, doesn't say what it stands for. Never mind that. I'm going to stop. Have I covered all the slides I wanted to cover? No, I've covered 0 of those slides. On Friday we'll have to rush a little bit, but I'll start with another Afrikaans summary of what I did today. Okay.